Hello everyone, and welcome to today's lesson with Everyday Seminar. Again, as usual, before we begin, let's go through the solution to our last lesson's problem. Now, there are 3 boxes, each with 2 drawers, 1, 2, 1, 2, 1, 2. Each drawer contains a coin. One box has a gold coin in each drawer, okay, a gold and a gold. One, a silver coin in each drawer, 2 silver coins, and the other, a gold coin and a silver coin. A box is chosen at random, so you take any box. So a box is chosen at random, and a random drawer is opened, and a gold coin is found inside of it. So the question is, what is the chance of the coin in the other drawer being gold? Okay. The answer to this. Now, keep in mind that the probability that you get the 2 gold coins, gold, would produce a gold coin. So the probability of the other coin being gold is 1, for sure. The probability that you get the the box with 2 silver coins, SS, would produce a gold coin, 0. Okay, there's no gold coin in the 2 silver coin box. Now, the probability that you get the gold and 1 silver box would produce a gold coin is 1/2. Okay? Most people think the answer is a half. They think it should be a half here and 1/2 here. Actually, it's 100% sure you'll get a gold coin. Therefore, so the probability that the chosen box are both gold becomes 2/3. So the answer, instead of a half, it's not a half, it's actually 2/3. Here you can see the formula. Probability of getting the gold, and the other one divided by the probability of all. So we've added the 1, the 0, and the half, and we have the 1 on top of it. Our answer, 2/3. Okay, let's move on. Okay, so our topic for today, we're still on probability theory, and today we're going to be doing the topic, we're going to cover a bit of expected values. Sometimes you see it like this, E of X or EV. Our key terms for today: expected values, a sum or total, discrete data, continuous data, probability distribution, a variance, the lottery or lotto, and a die or dice in plural. Okay, let's move on. Okay, now before we begin, let's go through some review questions. If you toss a die, what's the probability that you roll a 3 or less? Okay, 3 or less equals to a 1, 2, or 3. And so you take that over 1, 2, 3, 4, 5, 6. So the possible outcomes, here's your answer, are 1, 2, 3, 4, 5, 6. These are the possible outcomes, all outcomes. Getting a 1, 2, or 3 is half of the total possible outcomes. So here you have 1, 2, 3. Out of the total 6, 3/6 is a half. Okay, keep that in mind. Let's move on. So our second review question, 2 dice are rolled this time, and the sum of the face value is 6. What is the probability that at least one of the dice came up a 3? So you have 2 dice, and the total of that equals 6. So again, what we do here is we find out the possible combinations of the 2 dice. So here, I've written it here. You can either get a 1 and a 5, 5 and a 1, 2 and a 4, 4 and 2, or 3 and a 3. Now notice the question is, what is the probability that at least one of the dice came up with 3? So this is only 1 out of the 1, 2, 3, 4, 5 possible answers. And that's why our answer is 1/5. Let's move on. Okay, finally, here's a good practice problem. The number of patients seen in the ER or emergency room in any given hour is a random variable shown as X below. The probability distribution for X is here, P of X, probability of X, 0.4, that's 40%, 20%, 20%, 10%. So the question is, find the probability that in a given hour, exactly 14 patients arrive. So exactly 14, you can see from there, X equals 14, the probability is 10%. At least 12 patients arrive. At least 12 patients arrive. So we have 12, 13 plus 14, 20% plus 10% plus 10% equals 40%. Okay, at least 12, 12, 13, and 14. And the last one, at most 11 patients arrive, so no more than 11, so that's only 10 and 11. So here we have the probability of 10 plus the 11, 40% plus 20% equals 60%, or 0.6. Okay, can you see what we're doing here? Each of these numbers have a different percentage, different weight. This one occurs more than this, and this, and this, and this. 40% of the time, 10 people will be there. To get 13 people in the ER, that happens only 10% of the time. Okay, so basically that is more popular, more powerful, seeing 10 people. Okay, more on this shortly. Let's move on. So today we're going to be talking about the expected value. All probability distributions are characterized by an expected value. Okay? And, well, we're not going to cover that today, but this expected value also includes a variance. Some may see the expected value as the mean. Okay, in a way it's a mean, but it's a weighted mean. It's a weighted average. Let's go through that. Okay, so expected value of a random variable. Expected value is just the average or mean of a random variable x. Now, it's sometimes called a weighted average, the weight, because more frequent values of x are weighted more highly in the average. So like we did in our previous example, you have some have a 40%, some are 10%, some are 20. So there's more weight, more value on the x values with the higher probability percentage. Here's another way to write it. As you know, that's the mean. The E of x, expected value, in some cases EV. These symbols are used interchangeably. So sometimes we use EV, E of x. It's also how we expect x to behave on average over the long run. Okay? That's another definition of the expected value. Now, variables can be discrete or continuous. Okay, we're just going through this again. Discrete variables have a countable number of outcomes, okay, either dead or alive or a dice, 1, 2, 3, 4, 5, 6, counts 1, 2, 3, 4, 5, etc. And then we have what's known as continuous variables, and these have an infinite number of possible values. Examples here, we have blood pressure, weight, the speed of a car, real numbers from 1 to 6. An example, blood pressure, weight, you can have 126 kilograms, you can have 126.33 kilograms, and you can have 126.321, on and on. Okay, let's move on. Now here's the formal formula for discrete case, okay, E of x. So what we're going to do here is we're going to find the sum of all the x values, and then we're going to multiply it by its weight, or its percentage. And here it is for the continuous case. Don't worry much about that now. Now, have a look here. So recall the following probability distribution that we did earlier. Now, this, if we're looking for the expected value, what we do is we multiply each value of x by its percentage. So 10 multiplied by 0.4, then we add 11 times 0.2, or 20%, then we add 12 plus 0.2, and so forth. And then we find out that the expected value is 11.3. Okay, some might see this as the average or the mean. Now notice that on this balance here, we've put this point exactly here. And this point is supposed to be at 11.3. So at 11.3, this side is equal to that side. Okay, notice that there's a lot of weight on this side because of the higher percentages compared to these smaller ones. Okay, keep that in mind. Let's move on. Now, let's do this example, the lottery, a real-life example. Expected value is an extremely useful concept for good decision-making, so it can be very important in the real world. A certain lottery works by picking 6 numbers from 1 to 49. It costs $1 to play the lottery, and if you win $2 million after taxes. So, if you play this lottery once, what are your expected winnings or losses? Okay? What's the probability of winning or probability of losing? Now, as you can see here, first of all, we calculate the probability of winning in one try. So, we have 1 over 49 factorial, 43/6. So what we do is we can cancel that 49. It can just be 49 times 48 times 47 times 46 times 45 times 44 over 6 times 5 times 4 times 3 times 2 times 1. Okay, you know that. And then you get 7.2 times 10 to the power of -8. So that's like, this is basically 0.000000000072. Okay? Now notice that the probability function sums to 1. This plus that should add to 1, or 100%. And basically what it's saying, you have a 99.99% chance of losing $1. Okay, you're going to lose $1. But to win $2 million, you only have a 0.00072% chance to win. Okay? Now, what does that mean? So, we're going to look for our expected value. So, we've got the numbers. Probability to lose $1, 99.99999%. The probability of winning $2 million, 0.00000072. Now, expected value. So, the expected value, we take the, where is it here? Probability to win. Okay, times the probability, the amount of your winnings, the X value, times the percentage distribution. And then we add that to the chances of losing $1. So you're plus $2 million multiplied by the probability here, plus the probability of losing $1. And you get that value for here, and this value over here. So the final answer, your expected value, or the average, most likely you can say this is what's going to happen. Most likely you're going to lose 86 cents. So negative expected value is never good. Notice that's a negative. If you play the lottery, you're going to lose 86 cents. And you should not play if you expect to lose money. So this is a loss. Okay, let's move on. So expected value, if you play the lottery every week for 10 years, that's 52 times 10 years, 52 weeks, 10 years equals 520 weeks. What are your expected winnings or losses? So 520 times your expected value, which is a loss of 86 cents, equals losing $447.20. Okay, that's a lot of money if you look at it in 10 years. Okay, so today's quiz. A roulette wheel has the numbers 1 through 36, as well as 0 and 00. If you bet $1 that an odd number comes up, you win or lose $1 according to whether or not that event occurs. If random variable x denotes your net gain, x equals 1 with probability of 18 over 38. Notice that we have 38. So we have 36, 18 positive numbers, and 18 negative numbers. That's 36, plus the 0 and the 00, 38 numbers. So if random variable x denotes your net gain, x equals 1 with probability 18 over 38, and x equals -1, if you lose $1 with the probability of 20 over 38, what is the expected value of winning or losing? Another real-world question. And we'll go through the answer in our next lesson. Thank you for viewing today's lesson with Everyday Seminar. Hope to see you next time.